Welcome back to Made Up of Wires, where we've been decompiling Castlevania Symphony of the Night and working on the sword familiar. Right there. That's him. We're going to keep doing that today. If you're not familiar with the Castlevania Symphony of the Night decompilation project, go to soten.z.dev, where you can see progress on several of the overlays we've been working on. I haven't gotten the sword familiar up in this list yet. I will try to submit a PR for that later today. We do have several of the other familiars. The other new one that's been added recently is the demon familiar. Bat and Ghost have been completed, and it looks like Fairy. We worked on that a little while ago. That is done as well. And so we just have these two left, Demon and Sword for the US version, and then there's the Nose Demon, and then an alternate Fairy that I'm not sure what that is for other builds. So I have been working through several of these. I finished off the init function over the weekend and found a bunch of stuff along the way that may or may not have to be refactored. One of those being a structure that I added for a function that I wasn't sure what it did, but those arguments changed considerably. They were just matrices that we see in several other functions, but I hadn't identified those as that, and so I just had a temporary struct in place, but switching those over to matrices worked out, and probably will get that in with some of this other decomp work. The other thing that I found was there was a common header for the familiars that defined a color lookup table, actually two color lookup tables that were contiguous in memory. But for the sword familiar, those two color lookup tables exist, but they are not contiguous. So I had to do some if-defs to suppress that, but I'm not sure how that's going to work out in the future, whether or not. So some of the familiars use that common declaration, others don't. So maybe it's just something that lives in each familiar as opposed to being something that's common to all. So we're looking at the update servant default function today. I've gone through and I have about a 90% match just looking at the PS1 version. There's nothing overly complicated here, but there is some memory access down here that has been giving me problems. So I just pulled in the PSP version, and we'll probably spend most of the time at the beginning working through that and see if we can get a match on both of them. Matching both has been pretty straightforward for the last couple of functions that I've worked on. All right, so let's go over to the PSP side. I just imported this morning. It was a little tricky to find. There's not a lot of unique values in here that were relevant on both sides. I probably could have based it on the entity IDs, which do look like they are the same. Let's confirm that before I... yeah, those are the same. But I went a slightly more difficult route and based on the square root 12 function and RTAN functions as well, which allowed me to kind of zero in on which function that was. So we're just going to I haven't looked at this really, except to see that it's a relatively close match with what I have so far in the PS1 version. So I'm just going to go through and skim and see if there's obvious places to start, and I'll kind of talk through those as I go. The first thing I see here, so if you're not familiar with the decomp.me interface, we have an editor on the left, which is where C code goes that we're going to write and try to match. We're trying to match that with this target column. and what we're compiling to is in the current column. And we get little indicators in the current column to tell us where differences are, if there are any. The first difference here is a difference in stack space, which typically is local variables. Usually it's the opposite for PSP. I'm using one more variable here than the PSP version is using. And so that usually just means temporary variables that can't be optimized out or are in place that need to be fixed in some other way. The next thing I see is this mask. This mask indicates that we're pulling in this value, which is a signed 16-bit value, and then doing the comparison against 0. And it wants to mask off the top bits just in case there's something, so it can do a 32-bit load without having to worry about what's at the top there. We don't care about that, so we can do a lesser equality check, and it doesn't have to be cast to any value. Backing up a bit, it's not going to do a 32-bit load either way, but MetroWorks does put in that mask when you're doing an explicit numeric comparison rather than just a truthy comparison. It may not be the coding stream you need, but maybe it's the coding stream you deserve. All right, so we have some loads here that we have to be a little careful about because our offsets are going to be different between the PSP version and the PlayStation version. And what it looks like is maybe we're doing a plus equals and then doing the mask separately. So let's try that. And that looks like it worked out just like I expected, which isn't always the case. So occasionally we'll see immediate value differences. That's, in this case, it's jumping to a specific offset from the current program pointer. And we don't control that directly. We control that through other instructions. So we have to go find those and see where the differences are. Down on 63, I think I did tweak this a little bit. It looks like the way that this assignment is being done is just a different logical flow. So I'm going to try... I'm going to back this out. Oh no. As we're playing tricks on me, I'm going to try something like this. And it's not quite right yet. So we're putting our temporary variable into V1 and then doing the assignment, and it's possible it's just this where is this? It's possible that these are backwards. Oh no. this was the correct. It's not assigning this address directly. It's setting this temporary variable. We don't know what this is yet. There's a lot of stuff in here that I'm not quite sure of yet. I do have DuckStation pulled up, and so we might get into that a little later and see what we can do. So on 71, we kind of have an odd scenario where we're shifting the result of this our cosine function and then shifting that result again. And okay, that worked. I would expect that to be optimized down into a single 8-bit shift, but MetroWorks doesn't do that, so that's fine. On the GCC side, that's going to be optimized out. This I missed a struct access. This looks like it's probably going to be similar. When we're looking at the GCC version, often it's difficult to figure out if there are branching structures like this because of the way it gets optimized out. It'll do the assignment rather than branch, and then only have one edge of the branch in place. Alternatively, what often happens is that this global is assigned in both places, and GCC optimizes that out to a single assignment to reduce code size. All of this is actually fine and matching on the PS1 side. It's not till just about where we are, a little further down here on line 124, where there's problems on the PS1 side. But as long as I'm here, I will go through and try to get this as cleaned up as possible for the PSP. We see that shift by 4 with another shift by 4 again here. And we'll make sure we get all the parentheses we need. These all start at memory offset 80174170 is where the update servant default is. I can post that in chat. Of course, I can't copy from there. I do believe these all of these have been checked in as well. Let me open the GitHub repo and I can post that as well. So we're looking at the update servant default function, which is 80174170. So I'd expect so far that nothing that we've done will change the PlayStation version, but it's always nice to come back every once in a while and see if that's the case. This actually did reduce the match by 0.02%, or possibly 2 instructions, and I'd have to go see where that might have occurred. I actually don't see anything up top. And down below is all good as well. Yeah, I'd have to look into more details, but it's likely in here where this is not matching anyway, so I'm not concerned. All right, continuing on. So here's where we get to our first issue, which is a stack space alignment issue. The original stack is 16 bytes in size, but we're pulling from a 32-byte offset on the stack. And ultimately, we're going to have to figure out where that extra variable is. But it's easier to go through and fix instructions first and then worry about variables later when we can see what else is missing. And there's actually, most of this is pretty clean with the exception of the stack offsets. And then down on line 127 is where we finally get to something. And this is approximately the same place as the PlayStation 1 version. I will post this as well. Having these symbol tables is nice. And I really want to take some time and work on some of the remote debugging integration in either PCSXR or DuckStation, but just haven't gotten to that yet. Okay, so we can look at the decomp, but there's a few things that I'm noticing off. And this assignment of -400 is happening much earlier. And most of these are different offsets into our current entity. So we're either reading or writing back to different offsets here. So I'm going to reorder those. There are likely types that are incorrect. So I have to ignore these stack offset differences. It looks like offset 86, which right now is just unknown 86. The is currently marked as unsigned, but it is signed. That may be different on the PlayStation side, because I went through earlier and figured out the types there. So that clears that up. There's a sign extension here on 121, which means we're taking a 16-bit value and converting it to a 32-bit value. And that's this B0. So it's the result of this get target function. And let's look at that. So it looks like I just have the wrong signature there. I think this is correctly a assigned 16. I used the M2C's decompiled version of this to get the return value, but then pulled the rest of it from our header files. So I think I was mixed up on that, and I should copy that back to the PlayStation side just so I don't miss it. I will look at the sort familiar there as well. This struct, a bunch of things we don't know yet here. Oh, I got that for free when I did that copy. I just want to make sure that I change the sign to S. So the ordering down here now looks correct. And so that's very out of order from what the PlayStation 1 had. And I don't necessarily see a good reason for that. There's another call to abs to get the absolute value of this. It looks like it's just a repeat of the line above. This is one of the cases where I turn off built-in functions and declarations on the. Actually, this one, it doesn't make a difference either way because it's not using a built-in for MetroWorks. It is a function call. So I can change this to built-in abs. This will work regardless of whether I have built-ins turned on or off on the PlayStation side. I am going to take that and see what that looks like over on the PlayStation side. I just want to keep checking intermittently to see if things are getting closer or further. In this case, it got quite a bit further. The ordering of these is very much out of order. And these loads as well. I'm not going to worry about that too much yet, but it is something to note that the PSP is telling us one thing, and we're getting something fairly different on the GCC side. It is also possible that I have some of these incorrect or out of order when the symbols are different between the two platforms. It can be hard to tell. And the values are reasonably similar, the address offsets. So it is certainly possible that I have these wrong. So this is 2 bytes away. Sorry, it's 2 32-bit words away from the other address in this instruction. Whereas ours is only a single 32-bit value away. So there definitely might be something there. I'm going to keep going. So this looks like it may be a single store into a temporary variable. We're doing a second sign extension. into S4. Our ATAN should return a 32-bit value. Yeah, it does. And current X is also a 32-bit value, I believe. No, it's only a 16-bit value. So here we... it looks like we're using a temporary 32-bit value. And when this offset is being pulled from when it's being pulled from the stack, it looks like it's coming as a 32-bit value as well. So my guess is that this is being pulled somewhere else. So argument 0 is the sign extension of S4. S4 should be our current X. On the other side, and that's what's happening. We're not getting it from the variable, we're getting it from the field. And my guess is that this variable can go away and we'll get the same. Yep, that looks better. So sometimes all these little changes are subtle, but ultimately is what ends up working. So I think this is something relatively similar where this is being assigned directly to the result of the function. And then that field is being assigned here. And yeah, that worked out well. And so when GCC comes through, it says, I know the value of unknown 8C because I just assigned it. I don't need to go back and read it again. The memory model says that that value hasn't changed. And so we can somewhat infer what the name of this field is. So this is our target position. It looks like in the X coordinate. And then this down here all looks very familiar with what was happening in the bat familiar. I called this field follow to match what was happening in the bat familiar. I'm not sure yet that that's what it does, and we can pull this specific memory address, and that's actually probably a good idea after we get through this. We can pull that address and see if we can tell what's happening here. All right, so we're doing this assignment here, and then on the MetroWorks side, anytime we access a field again, it's going to do a load. And so this particular comparison has to be done against a variable so that we're not doing that load again. So we'll have to introduce a new variable. I think this is no longer being used, so we'll just use that one. And I think I did change this on the PlayStation side to eliminate the variable, because again, it doesn't matter on the PlayStation side when it's optimized. It wouldn't matter on the MetroWorks side if it was optimized either. And so what's a little strange here is that this is being forced into a variable, or a stack register. I will try to undo that and see if that does anything. So if neither of those things works and causes an additional register, this assignment may be happening in the condition. And that gives us a match. So we're really close on the PSP side. We still have a couple register issues. The stack space issue has resolved itself. So yeah, what we're left with really is just these few additional register swaps that need to be taken care of. I'm going to take this over and we'll see if this solved the PlayStation side or got us closer or further, and it looks like it solved it. So we have a match seemingly on the PlayStation side. And that's one of the reasons for pulling the PSP side. There was all of this trouble up here versus the ordering of these loads. And nothing changed here in terms of this code. Everything, all the changes were below it, and that's what ended up fixing this ordering. And so that's hard to reason about sometimes. Let's look at this down here and see if we can figure out what is going on besides browser crashing. So what I wanted to see is if we can tell down here on line maybe on line 157, what the differences are based on the sword level. I've not gone through and looked at any of this yet in the game. So what we want to do is find where, probably this offset here, where we're pulling sword stats, and then see, are we branching to the D5 entity, or sorry, D2 or D3 entities, and in what condition that is. So I'm going to, I want to go below the function call and go back to the PlayStation side, which also crashed. And look at those instructions. So it's around line 157. So we're doing this load upper immediate with 6666. This is how the division is done. There's some magic values used to optimize that division. But that actually gives us a pretty unique value to search for. So I'm going to go over to the terminal and load up the original assembly, which will give us the address offset for that particular instruction. So we're looking at the servant TT004. If Eldritch is still on, maybe he knows what the TT stands for. And we want the update non-matching in the sword file, update servant default, and we'll look for that. The load of that 6666. And so that's going to happen at address offset 80174608. And let's take this into DuckStation. Morning, Orkim. Good to have you back. So I'm going to add a breakpoint. So this is part of the this 80174117 function. This is the entry point address for this function. I'm going to disable that because that gets called on every frame, and that'll be very noisy. It's possible that this does, but it's a substate in the state machine for the sword familiar. The other one is a breakpoint for when you activate the sword familiar. And what I'm interested in seeing is if we can determine when one of these or the other is being selected, and then what that means. The familiar entities use the entity ID field slightly different. They kind of use it as their own internal state, apart from like a step or substep field, as we've called them. I don't think anywhere in here we're setting the step to 1. So I'm not quite sure yet either what gets us into this state. I'm assuming that it has something to do with targeting an enemy, since we do a lot of work up here to figure out position of some target, but we'll see. That's why we do it, so that we can tell what's going on. So I have the debugger open, and then you get to see me play Soten terribly. I'm going to unpause and turn down VLC. All right, so we're going to enable the sword card, which gets us our sword familiar. So my hypothesis right now is that state 1 for the sword card isn't going to be triggered until it has something to attack. And so we can go out and figure out if that's the case. All right, so we've hit our breakpoint, which means our step is 1. So this is looking reasonably promising that state 1 is our attack state for the sword. So I'm going to annotate that in decomp.me. And so this is where it would be nice to have slightly better debugger integration. But now we have to go through and step watching which instructions that we execute and which we don't during branches to see what side of that condition that we're falling onto. And so just to remind myself where we're going, so 158, we actually don't have a specific instruction because of the way GCC does this, but ultimately we're looking for this store half. Internally I always say high. store half word at offset 26. And going back to the DuckStation debugger, that is going to be down here on 4654. And we're looking for the value of V0. So we can pretty much step down to here, or we could add a breakpoint there and continue on, and then just inspect the value of V0. Right now, V0 is going to have values in it that we don't care about, but by the time it gets down here, it should have something. So we can either step through line by line and see when we get to the branch where we're going to go, which is all the way down here. So it's saying, is this is the value of V0 0? And it is. So we're going to get the D3. Sorry. We're branching if not equal to 0. So that means we're not going to branch. So we're going to fall through, which gives us D2. The instruction immediately after a branch or jump instruction is always executed. So GCC has come through and optimized this and basically said, no matter what, I'm going to assign D3. And if you look at the original automated decomp by M2C, that's exactly what you see is unconditionally assign register V0, the value of D3, then do the branch. Those are flipped. And then if the branch is successful, or if that instruction holds or condition holds, then we'll do the D2 assignment. When we're looking at it in MIPS assembly, though, we have to remember that that instruction is going to be executed regardless, and then we're going to fall through to the D2 condition. And then it's kind of up to GCC to decide, is it which instruction is more likely to happen? The branch likely is going to take more cycles than not branching. And so if we can, the OR immediate instruction is going to be faster. So we want to optimize that path, whether or not it actually could figure out which path to optimize. It doesn't have a JIT, so it'll never know. All right, so then it's going to do that store. So in our current state, basically, we're going to use the D3. The way, so based on the level, take the level, divide by 10, and then multiply by 3, which gives you whether or not we're going to use the D2 or D3 entities. So we can go back and look at that memory address where that data is coming from, and back into what that logic looks like. So there's some noise here because of how Splat decided to break this up. What I believe this should be is basically we have our sets of 3 values, and we're going to go to one of those. So let me pull up a spreadsheet. So we have to do integer division for our divide by 10. Off screen, I'm just gonna make a rough spreadsheet and see if I can get a sense of what these indexes are all going to be. So we're going to do a floor of level divided by 10. All right, and then multiply that by 3. What's a little strange about that? So we're always using the value at this third offset. So far these are all 0. Okay, here they've gone to 1. So how many down was that? So index 0. So now we're at 1, 2, 3, 4, 5, 6, 7. So it looks like it's not till you get to level 70 that that this particular check makes a difference. And let me look at that one more time. Yeah, that's what it looks like. So at level 70, the sword changes in some way that we'll have to figure out later. I can use the save editor to load a sword at level 70. And maybe that's worth doing. Let's go back to DuckStation and see if we can do that and trigger that case as well. So I'm going to disable these breakpoints. And we'll use the save editor, Mozilla's save editor. And I think I can update the sword familiar's level from here. If I can't, then we can move on. This check happens several other places as well, so it does seem like there's some additional ability you get at level 70. So let's use the stats editor. It does look like that doesn't allow me to edit the sword familiar stats, unfortunately. So that's not going to help. Okay. So we'll have to come back to that. I suppose I have the offsets for that, so we could just edit this in memory as well. Let's try to do that. So I'm going to basically go back and do the same thing. I'm going to enable my breakpoints. Okay. So before this can load, so we need to look at S0, which is here. And we're looking at offset 26 from S0. 26, that doesn't seem right. Oh, it's the stats. Is that right? It looks like that is the level is just the value of V0. So this is pulling from self. So what is V0 now? I'm not at the. Oh, I broke at the wrong place. So I'm gonna continue, and we'll load that again. All right. So let's get down to here where V0 is loaded. So now our V0 value is the address of where those stats are. Are the stats really at an even offset like that? It's possible. I did have that symbol table up. I don't see that as being the case. I see. So we haven't finished loading V0 quite yet. Oh no, we did. I will just edit this register. That's probably the most straightforward way to do it. So our level is 1, and we want a level of 70 or higher. So it's going to be 46 hex. And you will let me edit the register, won't you, DuckStation? Please. Well, I expected to just be able to type into this register whatever value I wanted. And I'm not seeing an obvious way to do that. Anybody in chat know how to edit the registers in DuckStation? Let's see the main interface if that gives us any options there. Oh, well, that's unfortunate. Okay, so let's go back and try again one more time. This time I will try to get the address first, and then edit the address prior to it being loaded. All right. I see. So we're looking at 801. Let me get a calculator. So currently V0 is so we're going to load the 8018. That's the top of our address, 8018. And then we're going to load 79B4. This is in the BSS section of this overlay, which that should be our level address. Let's go down to that address, and we should see, so we don't have the 80 when we're loading. The 80 just changes the addressing mode. So we're looking for 1879B4. And this does not look like what I want. Oh, because we're subtracting 79 before. So let's try that one more time. 8018. Oops. 8018. Minus 79 before. 801786. 8017. .864C. Oh, I'm at 18. Let's get down to 17. 178. 46. I would expect there to be a 1 here. But I do not see a 1. It does seem like I'm calculating this this offset incorrectly. This is the servant stat level. So I should be able to get that a different way. Let me look at the code. Sort stats. So I know the offset of that 8017.864C. Here's 4. Okay, here's our finally. So here's our 1. Now, is DuckStation going to let me edit this memory? Maybe not that either. Maybe this isn't something I can do in DuckStation. So it looks like I could edit the value in the memory card editor. I don't see an obvious way, though, to do it in DuckStation, which is a bummer. Oh. Oh, I could try just typing. That could work. All right, so let me, hopefully, I didn't screw that up too badly. So now when we load our branch, hopefully, so we're going to be looking down here, our branch should go to skip over, yeah. So now we're at D3. Let's undo this breakpoint. and then see what change we get, if any. It looks like that might not have worked. That address is set back to 01. Let me try one more time. There actually is another address, which is the current level, which may need to be set as well. That is 8658. Yeah, it's not showing up there though either. Looking back at the debugger, both those are in place. Yeah, so it didn't directly affect the level, and the level is back down to 01 on both of these. So there must be some other global stats that are overriding that value, unfortunately. So that's a bummer. More to learn there, but that's how this works. Try things, see what happens or what breaks, and what we can do. The other thing we can do is potentially just change those values and see what the change there is as well. Hey, Mozilla. Yeah, looking at the sword, familiar. Oh, nice. Thank you. So we'll go do that. We'll look at 9C or 97C78. So there was a global or something in the main game engine that is tracking that stat separate from the sword familiar overlay. So we're here, and there's our entire 8 experience, and we'll set it as Mozilla directs us, and is that big endian or little endian? Let's not gonna load state. Oh, what am I missing? Can do. Maybe. Let's get... Turn this breakpoint back off. Oh, there we go. Thank you. All right, so we will go back. Thank you, Mats. Turn that breakpoint back on. So what we're looking for is there's some different behavior at level 70, and we want to see if we can get some visual representation of what that might be, or behavioral change in the sword. I'm not seeing anything. Definitely nothing visual. We may have to go and find more more code to see what that entity does, and to kind of go back to where I was and getting down this path of wanting to find level 70. When we're doing updates to the sword familiar, the one thing we see is that there is the entity ID flips between mode or state D2 and D3. And if we look through the other code that we have so far decompiled for the sword, let's see if we have any other branches that are interested in either of those values. And oh, actually, those have been enumified. So let me grab the enums names for those. No, they still do have D5 and D2 and D3. So we just don't have that code yet. So more to learn. Oh, we do have some code. Still, yeah, I think still too early to figure that out. Just some really basic positioning code. So what we do know from this, though, is it does look like in the update servant default, when we're at step 1, or our step value is 1, the sword is in attack mode. And so we have one of those branches now for that mode, and then we'll have to see what how the entity ID affects that as we get more of that code. All right, so that's all the time I'm going to spend today streaming. We've been decompiling Castlevania Symphony of the Night, looking at the sword familiar, working on maybe the 10 or 11 functions still left there. Most of the difficult ones are still left to do, so there will be more. If you want to know more about decompiling Symphony of the Night, go to soten.z.dev, join us in Discord, where we're talking about all kinds of stuff. Some interesting work being done on the PSP EU version, which has one of the, what's the right way to say it? It is an early version with multi-language support, a little different from the other early versions. I've primarily been working on the PlayStation version, but also flipping back and forth to the PSP version for support. But yeah, go to soten.z.dev. You'll also find a link to the GitHub repo where, as we decompile things, we do code reviews and then people get it checked in. That's all I have for you today. Just checking out Mottzilla's comments, catching back up on those. Yeah, I don't know. We'll have to see whether what that change in behavior is. Really not sure yet what it might be. That happens several other places though, where an explicit check against this table is done, and it really just seems like it's. I guess there are a few different. Looking at some of this code now, there are a few different levels that are checked at various points, and so we'll have to see what those are because I do think that's kind of an interesting thing that I don't know currently about the sword. Familiar. Anyway, that's it. That's all I have for you. Thank you, and I'll be back Monday and Tuesday. In the United States, it is Thanksgiving week, and so I'm very thankful for all of you streaming. Very thankful for anybody liking, subscribing, following, doing all that kind of stuff. And I'll be back Tuesday and Wednesday, and then spending time with the family on Thursday. Adios, and I'll see you later. Bye.